Poisonous, venomous. What do these words actually mean? We realize that they mean that something is dangerous, but we might not always know how or why that something is dangerous because these terms are often used interchangeably. And yet, there are certain things we would only consider to be one or the other. For example, why would you call this mushroom poisonous but not venomous? That's because, perhaps only at a subconscious level, we realize that venomous and poisonous are words that have different meanings. But venoms and poisons do have many things in common. They are both toxins, which is to say that they are types of chemicals or proteins that are harmful to you. These toxins are commonly produced in order to be used against other organisms. Some are used as a weapon, others for defense. A few toxins are even used for both purposes. Toxins can enter our bodies by a variety of different routes. They can come into contact with open wounds or mucous membranes such as our eyes, nose, or mouth. They can be eaten, inhaled, or absorbed through our skin. They can even be injected into us by some sort of fang or stinger. Generally speaking, we consider poisons to be toxins that are consumed or absorbed through the skin, and venoms as toxins that are physically injected into other organisms. Now, poisons tend to serve to deter predators from eating them, whereas venoms tend to help organisms injure or kill their prey. If a predator eats a poisonous animal, like a toad, they can become sick and die. If a predator eats venomous animals, like spiders or wasps, nothing bad happens to them. Although you can be safely bitten by a toad, a bite from a spider or sting from a wasp can be lethal. So you can think of venomous and poisonous as being two sides of the same coin. On one hand, you're dangerous to eat, but you have a harmless bite. On the other hand, you have a dangerous bite or sting, but are harmless to eat. The reasoning for this dichotomy comes down to how and why each particular toxin evolved in the first place. Although poisons have no problem surviving the hostile environment in our stomachs, venoms are easily broken down in stomach acid because they're not meant to enter the body by that route. They're supposed to be injected into you. Now, even though poisons can't be used against prey, venom can be directed against predators as well as prey. In an effort to make things even more confusing, a few organisms are both venomous and poisonous, having different types of toxins in different locations of the body used for different purposes. So, why do we care about distinguishing between what's venomous and what's poisonous? Well, it's not so much for the sake of adults, but for those under our care, like children and pets. It's good to know whether or not that thing your cat brought to you is poisonous and is going to make your cat sick, or whether that creature that bit your kid has a venomous bite. Now, let's bring this discussion back to our scaly friends, the reptiles. What should we consider them to be? Venomous or poisonous? The Gila monster is one of the few species of venomous lizards in the entire world, but it doesn't need its venom to catch its favorite food, eggs. Having venom in a brightly colored body actually helps it ward off potential predators. Even though you can eat Gila monsters, since they are not poisonous, I wouldn't suggest it given the fact that their populations are considered to be threatened in many areas. Did you know that the bacteria living in the saliva in a Komodo dragon's mouth are not anything terribly dangerous or special? The Komodo dragon actually produces a venom, which inhibits clotting, causing their prey to bleed out for some time. When water buffalo are attacked by Komodo dragons, they often head straight for a water hole and soak their bodies in it to soothe their injuries. But in so doing, they seal their own fate by exposing their still open wounds to the filthy waters of the community bathroom. That's where nasty bacteria can enter the bite wounds and slowly kill the water buffalo from inside out. The western diamondback rattlesnake is one of the most iconic snakes in America. Much to our dismay, it is fully capable of using the venom it uses to weaken or kill its prey against us. Due to the fact it is a large-bodied, wide-ranging species with a fiery temperament, the western diamondback is likely responsible for more human suffering than any other venomous snake in the United States. That is probably one of the reasons why its venom is often used in the production of American antivenoms. Rattlesnake roundups are events held every year to celebrate the unchecked slaughter of tens of thousands of rattlesnakes, primarily western diamondbacks, for the purposes of barbaric and cruel entertainment. Animals are often skinned alive and tortured for hours before finally being beheaded, which, by the way, is not a humane way to euthanize a reptile. The good news is that little goes to waste at these events. The skin is often used for making articles of clothing. The venom is used in antivenom production and research. The meat is cooked up for human consumption, which tells us that rattlesnakes, like virtually all snakes, are not poisonous. They're venomous, plain and simple. In fact, provided you have an intact digestive system, with no open sores, bleeding gums, or ulcers, you could theoretically drink a vial of snake venom with no ill effects. Being primarily proteins, snake venom compounds would break down in the stomach just like any other protein would. Now, that said, it's still not something that you should try at home. There are only about 4 species of snakes in the world that we know to be poisonous. The tiger keelback snake of Southeast Asia and 3 species of garter snakes, similar to this one, that live along the west coast of the United States. Now, creatures wishing to make a snake sandwich out of these snakes would quickly find themselves either very ill or dead. But the neat part about these 4 snakes is that they don't even create their own poison. They steal it from their prey. Of course, these snakes must be highly resistant or immune to the poison in order to be able to safely eat their poisonous prey in the first place. When garter snakes eat poisonous newts, the poison, called tetrodotoxin, circulates throughout the body of the garter snake and is slowly metabolized and excreted over time. This allows the garter snake to become temporarily poisonous after each meal. Now, tiger keelback snakes, on the other hand, eat poisonous toads and sequester their toxins, which resemble bufotoxins, in a gland on the back of their neck, much like a toad does. This allows the snake to be poisonous for much longer than garter snakes, but not indefinitely. The strange thing is, these 4 snakes also produce their own venoms in venom glands, located right about here, for use against prey. So these 4 snakes are permanently venomous in order to help them get food, and transiently poisonous to protect them from becoming food. Now, just because something is venomous or poisonous doesn't necessarily mean that it's dangerous to people. For instance, we are already aware of the fact that virtually all spiders are venomous, but only a select few of them are actually dangerous to us. Some people like to refer to organisms as being mildly poisonous or highly venomous in order to represent their level of toxicity in humans. The toxicity of a toxin is related to the amount of specificity that it has for its biological targets. Although poisons are generally bad for any organism, venoms tend to target whichever prey the animal consumes the most. You could think of venoms and poisons as being keys for unlocking doors. More often than not, poisons are like skeleton keys, opening many doors and negatively affecting many different kinds of organisms. Venoms, on the other hand, can be like safety deposit box keys, only reacting with a specific target in one kind of organism. It's this specificity that helps determine how promising each of these compounds is for medical and pharmaceutical research. But that discussion is for another time. Before we go, let's take this opportunity to correct our poster. Well, I hope you've enjoyed our discussion on venomous and poisonous reptiles, and will join us for our next adventure on Beneath the Scales.